Okay, fifth graders, today we're doing Eureka Math Module 3, Lesson 6. And as you can remember from me saying yesterday, we're going to do Lesson 7 tomorrow. And then that's the first half of Module 3. So you'll have your mid-Module 3 test this Friday. Today we're still continuing on with what we learned yesterday about subtracting fractions. But today the difference is we are going to be subtracting the fractions from numbers that are between 1 and 2. So if a number is between 1 and 2, what does that mean? It's greater than 1. So, for example, who can give me a number that's between 1 and 2? Show it. 1 and 2/3. That's in between 1 and 2/3. So we're going to do 1 and 2/3 minus a fraction. Make sense? Compared to yesterday, where all of our fractions that we started with were already less than 1. Okay, so that's the only difference. So as promised, we are subtracting a fraction. In this case, we're subtracting 1/2 from a number between 1 and 2. Do you guys agree that 1 and 1/3 is between 1 and 2? Yeah. Good. So when we do that, you have two different strategies that you could do. Okay? And then basically I'm going to show you two strategies, and then sometimes one strategy might work better, sometimes the second strategy might work better. Okay? So the first strategy is to improperize the first number. We have 1 and 1/3. Well, we know that 1 and 1/3 is the same as 3/3 plus 1/3. Do you guys agree? Yes. Because here's the 1, right? And here's the 1/3. So if I have 3/3 or 1 plus 1/3, how many thirds do I have altogether? 4/3. 4/3. So one solution or one strategy is to rewrite that first term as an improper fraction. So if I rewrite this equation now, I have 4/3 minus 1/2. Now it looks like a fraction minus a fraction, right? Okay, so that's one way to deal with it. Now, are we ready to subtract? No, we still have unlike units, but luckily we have strategies for how to make our units the same or alike. So the first thing we do is we draw rectangular fraction models. If this is worth 1, how many thirds could I show? How many thirds could I show in one hole? 3. So I actually need to draw another hole and show that that's one hole in order to shade in 4/3, right? Because here's 3/3 and here's one more third. So I'm going to label this as 4/3. Okay? Now, similar to yesterday, we also have a second term, right? 1/2. So I'm going to show that this is one hole. And in this case, I only need one hole to show 1/2. Do you guys agree? Yeah. Okay. So there's 1/2. Now, if I overlap my lines, I'm going to cut that hole in half, cut that hole in half, and then make these into thirds. We can see that 1/2 is the same as how many sixths?
3/6.
Okay. Now over here, 4/3. Now one hole is still cut into 6 equal parts, right? I know altogether in 2 holes we have 12 parts, but we have to see, remember the units tell you how many equal parts one hole is cut into, so it's still 6. Do you guys see that? How many 6 have been shaded in?
8.
There's 6 in the first hole, right? But don't forget we have 2 more 6 here. So how many 6 do I have altogether? 8. 6. So how can I rewrite my problem now that I have like units? Instead of 4/3, I can write 8/6. Be careful. Addison loudly and boldly and wonderfully made a fabulous fill. That's so common. Oftentimes we do all this conversion work very well, and then we add instead of subtract. That is so common. So thank you for saying that so loudly. Right? How many of you could see yourself making a mistake like that? For sure. Yeah. Okay, so be careful. We always have to look. Am I adding or subtracting? Okay, now if I have 8/6 and I have to take away 3 of them, how many 6 do I have left?
5.
So the answer is 5/6. Okay, very good. Now, remember when I said there was 2 strategies, and the first strategy was making the first fraction into an improper fraction? Okay, so if we don't do that, our problem was 1/3 minus 1/2. You could just go ahead and draw 1 and 1/3. Right? And then if you take away 1/2, it looks like this, right? Okay, so go ahead and shade in. Let me just show you. It's basically the same thing though. So here's 1 and 1/3. Okay. Now, if we keep the whole number a whole number for now, still one whole, and I overlap these ones, I can see that 1/3 is equal to 2/6 and 1/2 is equal to 3/6. Do you guys agree? So if I rewrite the problem, I have 1 and 2/6 minus 3/6. Can I do 2/6 minus 3/6? No. So what does that tell you you need to do? You need to turn this 1 into 6/6 plus 2/6, right? Do you guys see that? And then take away 3/6. So then you would end up with 8/6 minus 3/6. So you kind of end up in the same place. It's just when are you turning it into an improper fraction that's different. Do you guys see that? Okay, good.